Okay, good morning, welcome to
FamilyMath770.
FamilyMath770. So a couple weeks ago, Alexander Bogomolny, our friend, posted a famous problem about a tetrahedron and a pyramid. Do you remember what the problem was?
So if you put a tetrahedron and a pyramid together of the same side lengths on their triangle face, then how many sides does the combined shape have?
Yeah, how many faces? How many faces? Okay, so you weren't part of this project, so tell me what you would initially guess about it.
So I would initially guess, since this has 5 faces and the tetrahedron has 4 faces, I would initially guess when you put them together that you would have a total of 7 faces.
Okay. Why 7?
Because
Why is that your guess?
when you put them together, you're losing a face from the tetrahedron, you're losing a face from the pyramid because this isn't on the outside of the shape anymore. But you're gaining the faces of all of them, of the combined shape, so it's 9 minus 2.
Alright, so make that shape right now.
So it's okay.
No, with the 2 shapes you have.
So like this?
Yeah. So what appears surprising when you make it?
Well, it looks like this is a flat face and this is a flat face.
Yeah. And in fact, when you actually make the shape, can you demonstrate what happens?
It is a flat face, so you can't move it at all on the ground.
So it's actually only, it's the same number. I think it's only 5 faces.
So you end up with
6.
count them. How many are there?
1, 2, 3, 4, 5.
Okay, so there's actually just 5 faces. And then we got quite a surprise as we continued forward, because our friend Patrick Honor was on My Favorite Theorem, the My Favorite Theorem podcast, and he talked about Varigno's theorem, which said if you take any 4 points in space and connect up the midpoints, any 4 points in space, form the midpoints, and then connect them up, you get a parallelogram. And someone responding to his blog post today, it's pretty neat to do that with a tetrahedron. So look at that big tetrahedron there. And let the corners of that tetrahedron be the 4 points. So where are the parallelograms when we connect up the midpoints?
You only need some of the midpoints, but there's squares here. And you've got one here. You've got one going this way. And then you've got one going like this.
Okay. And so, can you tell me, when you form all those squares, what do you get?
You get an octahedron.
So you get an octahedron inside of
Inside of the tetrahedron.
Inside of the tetrahedron. Okay. And a surprising, what's the surprise connection between these two shapes?
So the octahedron, if you cut it in half, you get the square pyramid. And then you can see that the shape that is created by the problem, then it actually appears.
Show me where.
So you take this square here, and then this pyramid in the corner here, they're already connected, and then the shape is outlined.
Yeah, can you pick it up and show it to the camera?
So it's...
This shape isn't comprised of 4 of these, it's 2 of these shapes. You've got this square here making the 2 pyramids here and here, and then the tetrahedrons coming off of them.
Alright.
And then it's 2 more tetrahedrons.
Okay, so it's a harder shape to show than I was guessing, but that's fine. Alright, let's move on to the next part.